Okay, so here's a quick video over pH and the pH scale. So what is pH? Well, pH is simply measuring, it was created to measure the concentration of hydrogen ions in any solution. So you're specifically, so pH, whenever you see pH, so pH is specifically measuring the hydrogen ion concentration in solutions. So that's what we're caring about. So that's why we have pH. So it's the H there is telling you that it's hydrogen ions. Okay, so we have different equations that can help us with pH. So we have pH equals the negative log of that hydrogen ion. We also know, so whenever you think about it, so it's all about whenever hydrogen ions break off into solution. So we have things that ionize in solution or dissociate in different solutions, and we're specifically considering water, but all solutions have ions break apart. So we learned that some things break apart completely. They completely dissociate or completely ionize. And so then that means that they're formed into their ions. And so whenever we think about pure water, which would be our basis for everything, water's two ions would be hydrogen ions and hydroxide ions. And hypothetically, that comes from water, which would be exactly 50-50, which means that water would be neutral because the hydrogen and the hydroxide would cancel each other out. And so we can also look at hydroxide ion presence. So we have a POH right here, which would be the negative log of the hydroxide ions. And this works in unison, I guess, with this. So our scale is on a 14 scale. And so if we take the pH plus the POH, we should get 14 every single time. So these three equations are the equations you're going to use to work any pH problem. So that being said, again, pH is just talking about how much hydrogen ions are in the solution, and POH would be talking about how much hydroxide ions are in solution. So you have to think about what's happening, what's dissociating, what's breaking apart. And so the easiest ones to start with are strong acids and strong bases. So a strong acid, for instance, and I will go ahead and list all 6 for you real fast. We'll go to the side for all 6. So we have hydrochloric acid, hydroiodic acid, hydrobromic acid. We also have nitric acid, sulfuric acid, and we have perchloric acid. Okay? And so those are our 6 strong acids. And so a strong acid is going to dissociate, a strong acid or a strong base is going to dissociate completely. So if we just take the first one, it breaks apart completely into these 2 ions. Like it breaks apart completely. There's no such thing as HCl, it just exists. When it's in solution, it is H plus ions and Cl minus ions. And so therefore, we have tons of hydroxide ions. And that's why it's classified as a strong acid, is because it completely dissociates, it completely breaks apart. We have weak acids that don't completely break apart. So you know acids, and so you could pick any other one and they would be weak. And so whenever you're plugging in the pH, literally it's super easy. If I tell you I have 2 molar concentration of this, so if I said I had a 2 molar concentration of this, if you think about the balanced equation for this guy, it would be HCl dissociates into H plus Cl minus. And you need to make sure that you balance, but it's already balanced for mass and for charge. So that means if I have 2 molars of this, and I were to do stoic, so then that means that I would have a 1-to-1 ratio. So that also means I have 2 molar hydrochloric acid. So for strong acids and strong bases, it's really easy. You just take whatever concentration that is, and you're plugging straight in. Because if you look at all of our strong acids, it's all a 1 ratio except for sulfuric acid. So if we did that one, that would be the only one. So if I said I had 2 molars of sulfuric acid, then we have H2SO4. And this is where in AP we start to break it down because it can actually dissociate twice. But we can have H plus HSO4 minus 1, which is what's going to happen when hydrogen will pop off first. But we also could have H2SO4, and then we have 2H plus SO4 minus 2. So depending on which one you have, so this one would be like a 1-to-2 ratio. And so with AP, we learned that the first one pops off completely, and then we learned that the second one, this is now a weak acid, and so for it to lose that second hydrogen, it doesn't lose it completely. That, don't worry about. I don't think UIL is going to ask you about that. But that being said, so you can kind of see what the process is, and then you're just plugging in those concentrations. So sometimes you may have to do, if it's a weak acid or a weak base, you just need to do a Rice table to be able to figure out the concentrations. So if you remember Rice tables, so Rice tables are going to be, if I have something like a weak acid, so we'll do HF breaks apart into hydrogen plus fluorine. So this is a weak acid. So our Rice table will be reaction, initial concentration. So if I say I have 2 molars of this, initially we have 0 and 0 of this. Then we have our change, which would be minus X plus X plus X. And then this is what it equals. So 2 minus X, and then just X and X. And so we have our Rice table for our change here. And then we can have our Ka, which would be equal to our products over our reactants. So I have an X times X over 2 minus X. So hopefully we're kind of remembering some of that AP stuff, but if not, that's okay. The big thing is plugging into those pH and pOH, and I can make more videos over it, so that way we kind of understand what's going on. If you're at the 14 range, if you're above 7, you're basic, and if you're below 7, you're acidic. So hopefully this is a little helpful, a little scatterbrained, pregnancy brain, but I covered most of the points I wanted to. I can also make YouTube videos just going through the AP notes, so that way we can make sure we hit each point. If you would like that, and you have copies of AP notes, and so we can always work through it a little better. Just let me know what you want.